All righty.
Okay, you should be host. You can take this starship out of the universe.
Okay.
Okay, link problem. Let's see how to fix that.
All right, is everyone able to see my screen? Okie doke. So what we're going to be doing in the lab is basically the same thing that we see in the lesson here. We're going to be using this data. Let's see, it might be up here. It's full of a whole bunch of real life data that we're going to be using. And what we want to do is essentially fill out this table. Now, what we're wanting to be able to say is, I can say with X% confidence that the flow value isn't going to get exceeded at this particular point. So for the first one, whatever value this is, I'm saying there's a 75% chance of there being a greater flow value this year, I suppose, than whatever that is. So over down here, there'll be a 0.001% chance of greater. So this is a once in 1,000 year kind of thing. All right, so how are we going to do that? Well, first thing is we want to get our data read in and into a data frame. So the code's already here to get it all read in. I'll briefly explain it. So you can see the number of columns we have going here. We're going to be appending stuff from our data into these columns, and then we're going to make the series from our data frame just those. So we could, if I wanted to, just print these out so you can see. So these will be the column headers, not column headers, the label name, column 1. This is the values here, and so on and so forth. Nothing really remarkable. We'll see them all when we print out our data frame. So we've made all of our columns. We put them all together into a data frame. Let's take a look. No surprise at all that the output is what was already there. It's not like we're changing the data frame or anything. Okay, so now we're getting into the actual part where we have to do stuff. Now, thankfully, 95% of the work we have to do is copy and pasting from the lecture. So let's go look. First thing we want to do is we're just plotting. Now, if I remember correctly, I was just reading the lesson. I think it just did this. Okay, let's see what we can do. So it might be a little different here, I think, because what are the types? That would be the thing. Okay. I want to know the type of the date column. So df date. All right, string. So that would be the first thing we have to deal with is when we try to just do the plot function, so we're wanting a plot of peaks versus date. Now, what are our columns? Peak flow is what it means. So peaks is in peak flow. So we want a plot of peak flow versus date. Problem is, both of those are strings. So what could we do in order to get this to plot? So if we look at the first plot in the lecture, let's see. I think we can copy most of this. Okay. So as you can see, in order to plot basically anything, I'll go ahead and yank the stuff that'll get these filled out, even though we're not using them. I'm going to get rid of this one. And I think that should be fine. So we can see that the plot function takes at least two arguments. These are the ones that are important. What's going to be in the x argument, or not the argument, the axis, and what's the y-axis. So we have some x. What is it? Well, let's go look. It seems to be a list of some sort, and it gets filled up with some stuff. What about YPDF? What's YPDF? It's a list of some sort, and it gets filled up with some stuff. So we have two lists of stuff. And we're saying, make the first list of stuff the x value, the input, and make the second list of stuff the y value, so the output. Make it blue. Throw it into our plot, and then we'll show the plot here in a bit. Let's see, what do you not like? Norm density. Yeah. Okay. Can put you here. Okay, so we plotted blue. Hooray. So using that knowledge, I've shown you how every piece of the puzzle works. We just have the wrong pieces. This is plotting stuff from, forget what even this data is about. It's stuff that we don't care about. What we want is peaks, peak flow. Actually, that should probably be the output, wouldn't you think? What's more constant, time or flow of stuff? What changes at a more constant rate? Yep, at least that's my opinion. So time as in date. And we'll call this one peak flow. And what do we want to call the whole thing? I don't know. We'll call it peaks versus date. Okay. So you have all the pieces, the puzzle pieces. We just need to reconfigure them. So what do I got to do in order to get the data I want to show up on this plot? Now, some data frames, as we can see in the lesson, will let you just plot it right out of the get-go. Like here. We can just do that. Sure would be nice. The issue is the data in our Beargrass data frame is all numeric. So we run into a problem in that ours isn't. So what shall we do? There's a couple ways to solve this. Would you change date X? I'm sorry, would you change X to df date? We can try that. But we're going to run into the same problem. Because essentially, when I call just the plot function, that's what it's doing. Is trying to do this df, and I think it's going to have the same problem. Is it lowercase? Yes. Now it may be smart enough to infer. No, it's not. Oh, hey, that's not the problem. So the error we got is that the dimensions aren't the same. Well, that's because I'm using data from what we want and then from the example, so they're not the same size. So let's see if df, this will be peak, right? Okay. Let's see, what did I do wrong? Flow. Okay, well, surprising to me, these values were strings, but I guess I guess it makes sense. We have a package here that is entirely dedicated to plotting. I guess it's smart enough to infer this is a string, but hey, interpret it as a number if you can. Okay, so hey, that was easier than I thought it was going to be. Okay, so we have our plot. It's ugly because the fact that the numbers are all smushed together. There's a way to turn them, but even then, if I turn them vertically like this, I can make the figure bigger. That's what I can do. Let's try 15 by 10. Okay, so that's a little bigger or better. But yeah, hey, we got what we want. All right, from here on out, almost everything is copy and paste from the lab. I'm sorry, from the lesson. So we're going to do the same process. I'm going to get the code. I'm going to yank out the code that we need. And then we're going to have to change some stuff probably. First one. Don't really need the lesson to figure out what to do here. What one magical method should I use? Yep. Okay. That one's always nice. So we know that there's 80 of each. The reason this is a 0 here is because let's see, where did the data frame actually show? I guess I never did I? All right, okay. It's because when we put the first column into our data frame, it doesn't have a name, so it's just 0. Okie doke. All right, we're going to do the plotting position function. And there's no man behind the curtain doing anything. Oh, we might do this too. There's no man behind the curtain doing anything sneaky. I'm just copying all this stuff. Now let's try doing just that. I want to see the first date. Okay. Now notice when we do the describe on the Beargrass data versus the data we have, we don't get quite as much stuff. What I would like to do, if possible, and if I can't figure out how to do it in like 2 minutes, then I'll drop it, is I'm going to take this column made of strings, and I'm going to try to column string to full. Okay. See what this does. It's not so much that I love Bing, it's that I specifically chose the Edge as the installation for my Anaconda. And for a couple of reasons. One, I don't use Edge, so anything, there's not going to be any extensions or bookmarks or all that fun stuff. But yeah, it's Bing, hooray. All right. So in our case, we want to see if we can just do this, make a date into date, but I want it as an integer. Hey, that's something. Let's see if that's stuck. Okay. And let's do the same thing for flow. It's kind of weird. Oh, right, because the date, that's why everything's so wonky on the date, is because the date looks like this. So I'm assuming this is like 1929, May 30th. Same thing for the flow. Okay. Now, what did all of that get us? Not a whole heck of a lot, but it lets us look with more than just knowing the count, basically. I don't know what the unit is for flow, but the max flow is what, 78,000? I'm assuming this is in like gallons or liters or something. Okay. Works for me. So we have a whole bunch of code that will put a not so well fitting Weibel function towards our data. Let's see if we can get that to work for us. So what do I need to change? I could just, there's no shame in doing what I'm about to do, is run it. There's a problem. Beargrass is not defined. Okay, well, I know that line 2 has an issue. So what all do we need to change? Yeah, Beargrass is the data frame we're looking at, or that's what it should be. And Beargrass is not the one that we have. We have DF. Is there anything else in this line I need to change? I suppose I can just run it and find out. Let's see. Key error. What's a key error? Well, our data frame behaves as a dictionary. So there's a problem with this. What's the problem with this? Well, there's no key in our data frame named peak. There is one called flow. So let's do that. Okay, what's next? NumPy is not defined. That is correct. NumPy is not in. Let's get it in. Okay. Oh, okay. Less changing than I thought. Okay, we've got our data and we have some kind of approximation. It's not terrible, but it's not great. What's next? Well, we are going to try to get, let's see, better using this, right? Fitting model. Okay. We're going to need both of these, I'm pretty sure. Okay. Okay. All right. Is there anything in here I need to change? You're getting the wrong graph. You're having problems getting columns to convert to integers. So first off, I don't even know if that's, I think that's the right way to go. I don't even know if it's mandatory though. If you haven't converted them and it's not working for you, then yeah, you probably should. So the line I did, the thing you need to be careful though with is what we've got going on here is, let's say I have a string, all right? Apple. Now I want to change my string so that there's an extra S on the end. This is like changing it to an integer. So I say this is equal to, well, I need X is equal to that. And then I need to say that X is equal to X plus S, whatever. Problem is, if I run this more than one time, it's going to keep adding S's. And that's the same thing we have going on here. If I run this more than once, I'm going to convert strings to integers. Okay, cool. And then I run it again. I'm going to try to convert integer to integer. So you only need to run this one time. But here's the syntax for how to convert a column into a different data type. Whatever your key is, you just put it in here and run it one time only. But if you're still having issues, let me know. Okay, where were we? All right, here. Is there anything we need to change? Well, that looks okay. Sample mean, where's that defined? Sample is there. So I believe we're going to need this too. Ba, 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 ba. No, it's just doing the same thing, I believe. I think we have sample mean and sample variance in the cell above. I mean this one. I don't know if we need these two, but we'll find out. Let's see. So I'm gonna hope that we don't need those because we already got our plot. Okay. See what happens. Huh, okay, it ran. I wonder what'll happen if I just, nope, okay. X and Y the same size. Alrighty. So the one we're wanting to do is this here. Then we would like to apply it like that. Okay, so what is error is that X and Y must be the same size. So let's see, what is their size? Where did you get the code for the quantile function cell? Well, there's more than one. What we're wanting to do is get a function for us that'll let us make a nicer plot here. So see the quantile value. So this is where I'm starting. The issue is that we have some stuff we need that's not defined. So we need to go through that. So, okay, let's check those to see. All right. I'm pretty sure the issue is that we just aren't plugging in our data. So where do we plug in our data? So this is just making, try to change the column to integers, change my entire data frame. That's weird. If you can copy and paste the line for me, I'll see what I can tell you. Now, I may be wrong here, but I think this is what we can change. Surely not. All right, I'll take a look at that in a second. Because right now, what we're wanting to do, figure this part out. All right, that's the yucky one. This is the log one. And that's right. That's the next part. So what we're trying to do right now is this. All we need to do is figure out where our data plugs in to here. So see, the thing that's confused me, let's print out sample so you can see. Print sample. We have a list of stuff, right? And that's what we're using to get our mean and our variance. Now the trick is we have two lists of things. And we need to figure out, so we've got our Y, CDF, and our X. We can figure out which one needs to go there. And I don't know. Luckily, this part's a lot easier. But I can always do this. Print YCDF. Okay. $101. And then what about that? Okay, so that's not the problem. 25. That doesn't seem right. Okay, so that's probably our issue. So 80 is the amount we have. So this one's correct and sample isn't. All right, we're getting somewhere. So sample has length 25. Now, where on earth would 25 come from? Here. And why would it be 25? Well, I would bet you some money because the amount of stuff in the example was 25. So let's change this to what, 80 was it? Oops, don't need that. Okay. Now, as you can see, the blue stuff isn't exactly what we want. We want the blue stuff to be this. So let's look here. Now, I'll explain the problem before I try to fix it. The blue, let's see. Someone says, I think get rid of the lines where starts the population equals blah. So that would be here. Yeah. So what's happening is the sample is sampling from a random distribution of stuff, which isn't really what we're wanting. We're wanting it to be sampling from our data. So let's go ahead and just get rid of that. The thing, maybe we just try this. I don't think this is what needs to go in. You have sample, there's a sample in the Weibull plotting part. Okay. Yeah, I see that the sample's defined there. Okay, well, I got rid of that. Let's just do everything all over. Okay. Oh, what is it? Date. Okay. Okay. Huh. And I got rid of the population thing. I guess I'll restart the kernel. You've removed sample. This part here. Started at mu equals sample me. Okay, well, let's try it. Kapow. Well, that's something. We need the part that gets the approximation of our red line here. So if I'm not mistaken, this is the same thing. Let's see, what's YCDF? Get placed here. Okay, well, I think about that. Let me show you how to do this last part, because this is what's going to be really important. You see, when we were, we've got our bear grass data here. What we want is to be able to input something to this normal distribution with a guess and see if we can get this number here to exceed whatever thing we're interested in. So on a guess of 6,000, I got 36. Okay. Now you could play the game of messing around with this. So that went down, what, 3? I can play this game of getting as close to this number as I can by guessing, but we have this nice function here. Now, what we were doing just right here, which is 6,000, 2,000, 4,000, whatever, this is doing the same thing. It's doing a method where blah, blah, blah. There's some in here somewhere is the correct guess. So I'm going to go halfway, see how it changed. And then let's say I went too far to the right. Okay, I'll go halfway, see how it changed. And then I'll keep doing this game. That's what this method is going to be doing. So it takes smart guessing and automates it. Don't need you right now. Okay, so what's the quantile we want? Let's say 25. And we want the mu and the sigma to be from our actual data, right? Let's see, where are you defined? Oh, we already did. They're here, right? Yeah. So this should work. Okay. Just to illustrate the point, so 25. And what I'll do is say print this at, we'll make this a value, okay? So newt this. And then we'll print out. The mu and sigma were calculated here from sample mean and sample variance, which get defined here. And this is from the flow. So we don't have any, are they reset in the function? Right, that's weird. So here's what we'll do. Mu, sigma, and I'll even get smarter, quantile. So what we're gonna do is we're gonna change this function up a little bit. What am I doing here? I don't even see F getting called. Oh, duh. It's because the thing we actually were doing All right. This is the function. I see. So the reason these are hard coded. Huh. So first thing I want to do is print out mu and sigma. Here's mu. Here's sigma. There we go. Okay. So now we have our Newton approximation of F here, print it out, and then we'll get the actual thing. So what did it say to 1128? That's pretty nice. It's pretty close. What about if I do like 1200? I like the 1128 better. Okay. Okay. So that's that. What if I want to do it for, I don't know, 99.8? Well, this is the 25 exceedance probability, so I want 99.8. So what do I get out? 54,164. Let's try doing that. 99.79. That seems pretty close. Now, this guess here is not needed for the value that is correct is going to come out here. So I don't have to re-change the my guess and rerun it. But the reason I'm doing that is so that I mean, heck, I can do this. Let's see. This, right? I can just do it this way. So this will be approximated flow value. Okay. And then this will be using approximated flow value in our data. Okay. So I don't really need to keep redoing that. The reason that mu, sigma, and quantile are hard coded is because you see we're not actually calling f. F is our function. We're not actually saying f of x. We're doing a thing called function application. I don't expect you to understand what it means. Just know that when you're repeating this method for whatever data you have, because that's the homework, that the mu and the sigma will need to be hard coded, and this is for flow. So let us return here. We are at the time limit, but I'm going to keep. I want the red to show up nicely, so let's see. It's just something simple I'm missing. It's a wire I haven't plugged in. So let's see. All right, so sample is length 80. I want to see YCDF. Let's print YCDF. Are there any questions on this part? Because this is the meat and potatoes of the homework. Say YCDF. Okay. About X. I don't think that seems right. I think might have a guess is what the problem is. Yeah. So here's the issue. The X range for blue is from 0 to 1.0. However, what's sample? A lot. The range, CDF, for our YCDF only moves through here. So there's something wrong in our YCDF. Okay. One. Okay, I don't see any questions on that. Let's see. Hunter, your question. Data frame, column 0. I don't know if you can do it at the start. So what you're trying to do is just do it all in one go. I think you may have to run this and then make the columns. So I don't know about that. Okay. Back to me trying to figure this one out. In a small explanation, y ball p, you can see this ranges from 0.01 to 0.98 as expected. However, when we look at, and that's the x-axis for the first thing we want. When we look at the x-axis for the second thing we want, YCDF, we can see it ranges from 0.22 to 0.22. Everything's the same. That's the issue. So if I can figure out YCDF starts out blank, and then in our loop here, we're going to append this. Now our mu and sigma, the right things. I'm thinking not. Where are those even defined? Sample, oh, here it is. As soon as okay. NumPy array sample, okay. Seems right to me. Sample, it's our flow. So sample mean and sample variant seem to be okay. The mean should be like 11,200. Print. Sample mean. Okay. Yeah, seems right. Just to be extra diligent, I'll print it again here. Mu. Okay. Sample variance. If I do the yeah, print sigma 14,928. Pretty close. All right. So the mu and the sigma are fine. So it's got to be this. Again, now obviously I'm way over time. This is, but I'm going to finish this out so that in the recording it'll be there because I think it's important. But if anybody else has any bright ideas, that's also nice. So again, what's going on is our X in the blue ranges from 0.01 to 0.98. Our X for our red range is basically nothing. So when we go in here and make our YCDF, it's not doing what we want. And so I need to figure out why. So if I say X high minus X low, it's going to be 1 divided, so 1 over 100, okay? What am I doing wrong? Maybe I'll try doing this one instead. Way up here. Hey. Cool. All right. Well, that's nice to not have weighing on me now. So you can see fixed our issue. The blue, which is our data, ranges from 0.01 to 0.98. And now the red ranges from 0.2 to 0.99. So that feels better. All right. What did I change? I went to the bear grass data and just ripped the entire section. Rather than using the one from above. Now let this be a lesson to everyone. Couple things. One, just because you get stuck on something in front of 50 people and a recording, doesn't mean you're stupid, doesn't mean that the machine hates you. It happens. Two, I'm copying and pasting a method, and that method is, what are we calling it? The normal quantile function part. Well, we did that twice here in the lesson. And I picked one. I tinkered with it for 20, 30 minutes. It was probably a bit too much. It wasn't working, so okay, I'll go try the other one. So I tried this one instead. And lo and behold, as soon as I slap it in there, it works. All right. So that's this part for getting the plot. Let me get rid of these ugly numbers. Now you can change the name if you want. And then the other part, which is filling out this chart, is right here. Now in the homework, if I remember correctly, there are like normal and log normal and all this fun stuff. Don't freak out. The only thing that's changing is this is just the normal distribution. Well, we can take the log of this right here. Just a simple change in, let's see, where's the first one? Right here. So we're applying a logarithm to everything in there. So just because it says, oh, what the heck is log normal? That's it. Okay. And I think the same thing goes here. So another, that's in the homework too. Right here. Again, don't freak out. It's just applying this function to our data. I expect to get a lot of questions about these parts. That's fine. Okay, everyone's gone. That's fine. It's recorded. Can't think of anything else useful to say. So I will see you all later.